Let's talk about apply functions and or apply like functions. And if you want to avoid your for loops, you may want to use apply functions. Please remember that R is a vector-based programming language. Then if you write your functions in an apply mode, then your code chunk will be more R types in here. Let's see what I'm talking about. One of the most common or the first apply functions is the apply one. You may see that you should give some X, margin, and function in here. And apply can be used with array or a matrix. And you should give a margin, which is a vector with subscripts. For a matrix, one, when you say one, it indicates rows, two indicates columns. If you give C, 1, 2, and that indicates rows and columns. And function can be, like, please remember we were giving X and margin, we talk about them, and we were also giving function in here. And this function will be the applied one, and it can be an R function, or you can write your own function in here. This is the general shape, how we see apply functions. And it is kind of supplementary tools for loops. And generally they work faster, but not always. You should try for your own examples. And as an example, let's generate a 5 by 6 dimensional matrix from a normal distribution. And I will give it a name as X, and let's use matrix function in here. I want to get 30 standard normal variables, and number of rows is 5, and number of columns is going to be 6 in here. And I'm generating 30 normal random in here, random normal numbers. Okay, so this is my matrix, and if I want to apply any function in here, I can use apply. If I say, if I give my matrix and let's get margin as 2, that means I'm going to do my function by columns. And let's see if I can do sum for each column. When I run this part, you will see that for each column, it's going to give you the sum of them. And of course, there's a function which is sum call sums. And if you give the X one, it's going to give you the same one, and which is very easy. But we are not always using sum function here. You may want to use some more advanced functions instead of sum. And then you may want to use apply functions in here. And let's generate a matrix from 3 different normal distributions, not like the previous one. I want to give it a name as M, or like M matrix. And here is my data. I want to column bind my data. The first one is from a normal distribution, 15, 0. Second one is again from normal distribution with 15 and 2. And the third one is again from normal distribution, 15 and 5. Okie dokie. We are trying to generate 15 different random variables from 3 different normal distribution with 0, 2, and 5 means in here. And I want to say that my matrix number of rows is going to be 15, of course, and number of columns is going to be 3. Here is my M. I have this matrix, And so if you want to take the mean for each column, you may say that, okay, please get the mean for my M for the first column in here, and mean of the second column, and mean of the third column. Here. You see, it's not that beautiful in here. You can use this method, but there's always different alternatives in R to do the same job. Let's say you want to use apply function for M, and your margin is going to be 2 because you want to get the mean values for each column. Then here is your results in here. If you want to do the same job for row buys, then you can just save 1, and then you are going to get 15 different mean values in here. Okay. Let's say for M, you want to get the number of negative values for each column in here. Okay. And apply. And I want to use my M for each column. I want to use a function of X, and let's say the length of X smaller 0, okay, smaller than 0. And you see that in the first column, we have 4 negative values, and we don't have any negative values in the second and the third column in here, and you can see it easily in this example. Okay, of course yours is going to be different than mine because we are generating random numbers, then your random numbers are going to be different than my random numbers in here. Okay, and so please remember the first argument for apply function is asking for a matrix or an array. And let's do more examples. We have X, and I want to generate a matrix for this X from, again, normal distribution. Let's say I have 2 different numbers, and 20 and 10. And here is my X matrix in here. And I want to get the quartiles for this one. How can I do that? I want to use apply function in here. I will use X matrix. And for each row, I want to get the quantile. So you can add any options for your function in here, because remember we had ellipses, like 3 dots in there. Then we can add more options in here. I want to add the first and the third quantile. 0.75. And oh, sorry guys, this should be, yes. For each row, we get the first and third quantiles for this matrix for our data sets and for each row, okay? And let's try it with an array. It is also possible to use these apply functions with arrays. And here is my A. I'm going to generate an array by using array function. Let's generate random numbers. 2 times 2 times 10. And my Z is 2, 2, and 10. Here is my A. I have 10 matrix and 10-dimensional array, and each of them are 2 by 2. For each of these guys, the items of my array, I want to get the mean values in here. So with apply function, by getting this A, we want to do it for rows and columns. And let's say you want to use mean function. And now for all of them, we get the mean values for the first values of this array, this one, And this is the mean of the 10 items in 1, 2 elements in here. Okay, same for all of them. And there's one function defined in R, which is row means, and it just does the same job and in a faster way. Yeah, this is easier and faster, and there's always alternatives in R you can use. So let's share R again. Okay. So second alternative of apply function is the sapply. Then another alternative in here, and S is for simplified. And so for S function, sapply works with a vector or an array, and it returns a vector or matrix by default. Okay, and if you simplify it, and so by using sapply, let's write it, we will give a list. So for each element of this list, the function will be run by R in here, okay? So sapply returns the results by applying each element of X to the corresponding element of function in here. Okay, let's see it in an example. I think it's going to be much easier to get the idea. Sapply, and let's give a vector 10, 20, 30, very basic example in here, and I want to give a function of x squared. Okay, so for each element in here, R is going to run this function, and when you see, it's just getting the square of 10, 20, and 30. And let's give another example. Sapply, give a vector 10 minus 20 and minus 30. My function is just absolute value. And here is just giving me the absolute value of each element in here. And we can generate another example. It's also working with characters in here. Let's say I'm going to use sapply again for 1. These are characters. They're not numbers. 2 and 3 options. And my function gets all of these values, and it put it to this function. I want to paste x with Mississippi. Oh, I'm doing typo again. And the separator, sorry guys, is going to be tab. Okay, so when I run this part, it just get 1 and paste it to Mississippi. Okay, and 1 Mississippi. And maybe if you want to give a blank, it's going to be much better. Okay, 1 Mississippi, and get the second value as X and paste it to Mississippi, and again 3 to Mississippi. Okay, just doing the same job for each of your elements in your vector or in your list you are giving here. And we already said that it also works with lists in here. And let's say I have my list, and here is my list, and I want to fill all elements of my list. Like the first one is going to be something numeric, like 10, 20, 30, and 40. And my list and second element is going to be, let's say, 1000, 2000, and 7000. Here is a second element. Let's see my list. You see I have 2 elements for my list, and I want to get mean of each of them, okay? So I can use sapply for my list, and it will get each element and just apply this function. And here is very easy. and you may want to use, and your output is a vector, and if you want, you can just add an option here. Let's add an option like simplify equals false. Then it's not going to simplify your results, and your result is again going to be a list. Okay. And here is one more example. Please remember our previous M matrix. For each of its elements, I'm going to get the mean value. Sorry guys, let's delete and just write mean. And what you want to do is you want to get the mean of M was capital I guess, and for each X values, but maybe it's better idea to add function of X. Yes. So I'm going to get the mean values for each of them. Please remember we had this M matrix, and now for each column from 1 to 3, you see that we show that with blank and comma. And for each column, I'm going to find the mean values by using sapply function in here. And if you want to do it row based, let's see, I will get this guy. And instead of columns, I want to use rows. Now you have, like, if you use this one, like 1 to 3, you will get it for first 3. And if you have 15, now you will get for your means for each of your rows in here. Okay. The next function in here is lapply. Lapply. And L in here is stand for list of apply. That means the output of lapply is giving you list, and it's very similar to sapply, and it just differs by their returning in here. So lapply is just loops over a list, iterating over each element in that list, and it applies a function to each element of the list in here. Let's see with an example. First, remember we were using sapply, and let's say 1 to 3, I want to have my function of X like X squared of that. And here is my result. And if I use lapply instead of my sapply, it is the same guy in here. We can just use this part. And instead of a vector, the result is going to be a list now. Okay. And sometimes it's really useful for us to use lapply when we are using more complicated functions in here. And let's say if you want to simplify sapply, let's say I want to remove simplify in sapply, then we have the same. This guy and this guy are giving the same results in here. Okay. And also, if you unlist your lapply result, let's say I not unlist my lapply, then the result is going to be vector, which is same as the result of sapply in here. Let's give more examples. I want to generate my myself files, and let's say from 1 to 10, I want to generate a function of X. Let's paste 0, my file, add X, and at the end add CSV. So I want to give it a name, files of mine. So I'm getting from 1 to 10. Here 1 to 10. For each of these values, it's just getting my file, character, adding X and CSV at the end. Here is my files. I'm generating file names for myself. File 1 CSV, file 2 CSV. You see that this is a recursive job in here. And also if you want to see it in a better format, you can just unlist your files and you will see them like that, and you can use that names later on. So you can use lapply to evaluate a function multiple times, each with a different argument in here. Let's say I have my x from 1 to 4, and if I apply for my x and just uniform distribution, if I want to generate random number from a uniform distribution, for the first one, it's just generating with 1 random variable, and then 2 random variable, and 3 and 4, because I said x is 1 to 4. So I just evaluated my function multiple times, each with a different argument. Okay, and of course you can play with your uniform random variable options. Let's say my minimum value is going to be 0, and you can add your options after your function. Now you change your options. The minimum is going to be 0 and the maximum is going to be 10 this time. Okay. So let's do more examples. I want to generate a list that contains 2 matrices. Here is my list. I'm generating my list by using this function. A is matrix from 1 to 4 and 2 by 2. And my B matrix in here is from 1 to 6 this time and 3 by 2. When I generate my X, you will see I have first element is a matrix 2 by 2, second element is a matrix again, the name is B, 3 by 2. Now extract the first column of each matrix in the list. So we can use lapply because you can give a list as an input in lapply function. So I can use my lapply and give my X list, and this time for my function, let's say for each element, let's give it a name, an arbitrary name. You can just even say apple there. And for for all of them, I want to get xt comma 1. Okay, so this is just extracting the first column of each matrix in the list. And you see this is my first column here, 1 and 2, and 1 and 3 is the second in B in here, and I can do it in lapply. Or you can write your function first. Let's say I want to write my function first to make it easy to read, xt, and here is my function. What was I doing is that I was getting the first columns in here, and here is my function. Now I can use lapply for my x, and now my function is f, and I think our x was capital in here, yes. For each element, it's just running this function, and you can change this. You can write whatever you want in here. You can change the body of the function in here. Okay, so please notice that sapply calls lapply on its input and then applies the following algorithms. If the result is a list where every element is length 1, then a vector is returned. If the result is a list where every element is a vector of the same length and greater than 1, a matrix is returned. If it can't figure things out, if it if it doesn't know what is the return in here, a list is returned in here. Okay. So we used apply, sapply, and lapply functions so far. And now I want to move to mapply function, which is multivariate apply. Let's see, mapply. So when you write mapply, it's kind of different. Now you have to give the function first, and mapply applies that function to multiple lists or multiple vector arguments in here. Now it's kind of different use. Let's generate a vector first. Very simple one. And here is the second one. Let's say 7,000. I think we used them before. B1 and B2. Now here is my function. Here is my function. I want to write a new function for myself. In this function, I want to get X and Y as arguments, and I will just sum them. Okay, you can write whatever you want. Here is my function. Now I'm going to use mapply with my function for V1 and V2. So now you see that it's just summing the first guy and the second guy, first guy of V1 and first guy of V2, second one, the third one, and the third one. And when it's come to the last one, you see that the V2 has 3 elements, but V1 has 4 elements. Please remember the recycling option of R. And now it's going to recycle the smaller one and then give the first one as the 4th element and just sum with 40 with 1000. Okay, please remember the recycling here. And let's move to another example. I want to generate another matrix and give it a name as Q1. Here is my matrix. I will have 1 4 times and 2 4 times, and again 3 4 times, and again 4 4 times. It is my Q1 matrix, and please give the dimensions 4, and here is my Q1 dimensions. Okay, there are several ways that you can generate the same matrix, even easiest ones, but I want to use my mapply function to generate the same matrix. Let's use mapply. You want to wrap. Here is my function. You should give at least 2 inputs in here. Get 1 to 4 and 4 times. And when you write Q2, voila, you have the same matrix with the same elements. Okay, and it's kind of easier by using this one. You will see that this wrap is our function. It's going to repeat 1 4 times, 2 4 times, 3 4 times, and 4 4 times. Okay, and actually if you just add one option in here, and let's say if you say simplify as false, now you will see that instead of matrix, you are going to have a list as an output in here. Okay, and if you want to use more arguments, and I can just use again my mapply function with more arguments. I want to repeat again. Sorry guys, how many times? 1 to 4. And there's one more option in here that we can use more arguments let's say I want to use a list of X and I want to write data in here. Here is, I'm just repeating this part and I just wrote data, but you can even write anything you want. Let's say you want to write pizza, and here is 1 pizza, 2, 3, and 4. Okay, it's just repeating this pizza for how many times? 1, 2, 3, and 4 times. Okay, let's do something interesting in here. I want to repeat again from 1 to 4, 4 to 1. Okay, I'm repeating 1 4 times. I'm repeating 2 3 times. I'm repeating 3 2 times. I'm repeating 4 1 times, depending on my apply function. Let's do more examples to make it more clear for you, okay? So let's write a function, and I want to write a function by giving mean and st as my arguments. And inside of this function, we are going to generate random number variables and random number variables with mean and st, okay? And you should give it a name to use it later. And here is my function, okay? And let's say I want to generate 5 random variables with mean 1 and standard deviation 2. Here are my random variables in here. Let's try this one. I want to generate from 1 to 5 variables, from 1 to 5 mean for 2. So what is you are expecting here? Please think about it. But the result is, it is only simulating one set of numbers, okay? Not 5 of them. So I want to get first 1s and 2 and 3 and 4 and 5 in here, but it just used 5, the last one, to generate 5 random variables. But I'm just looking for something different. I want to pass the sequence 1 to 5 separately to the noise function so that we can get 5 sets of random numbers and each with a different length and mean in here. So for this one, we should use mapply. Mapply, my function is noise. So from 1 to 5 and 1 to 5 and 2. First, I'm giving my function and I should give the arguments in here. 1 to 5 is n. It's going to get 1 first and 2 second and 3 as the third one, 4 and 5 later. And the mean is going to change from 1 to 5, okay? So when I run this one, you see that this is the first one. This is the second one, third one, fourth one, and the fifth one, okay? So it is same as calling the function. Let me write here. It's almost same like writing this guy in here, okay? And they are doing the same job for us.